Since the dawn of man, humanity has pondered an age old question: where are we? The answer to this question lies in the brightest stars of the night sky and in the deepest, darkest depths of our infinite universe. In late 2021, our investigation of the universe and its mysteries was progressed when the James Webb Space Telescope was launched into orbit. It was the culmination of years of engineering and construction and serves as humanity's key to understanding the cosmos. This monumental telescope also serves, however, as a reminder of the work done by its iconic predecessor, the Hubble Space Telescope. Hubble contributed to both our understanding of the universe and progressed key aerospace manufacturers, many of whom are based in Colorado. In doing so, the Hubble Space Telescope served as a pivotal chapter in the frontiers of space exploration and Colorado's economic development. To truly understand the legacy of Hubble, we must first venture into a brief history of space exploration. The first example of a liquid-fueled rocket that served as the start of spaceflight as we know it today was created by Robert Goddard in 1926. Rockets would be further developed during World War II when the Nazis designed the liquid-fueled V-2 rocket to bomb enemy territory. After the war, the Soviet space program, created in 1952, and NASA, created in 1958, competed in a space race that was driven by military and political motives. NASA would eventually gain the upper hand in this race with its Apollo program, which famously sent astronauts to the moon. Even while men were walking on the moon, however, the fleeting political and military momentum that drove space exploration ceased, and NASA's goals changed as a result. Instead of continuing its costly moon missions, NASA began normalizing spaceflight and reducing costs. These goals called for the development of the space shuttle, which would serve as an efficient platform through which major scientific progress in space could be achieved. Ultimately, it was this spacecraft that would make the Hubble Space Telescope's creation and maintenance possible. To make Hubble a reality not only required spaceflight technology, but also the vision and motivation to create an orbital space telescope. Humanity's interest in the cosmos far preceded the telescope in even known history. In fact, archaeological records suggest that astronomy was one of the first forms of natural science. Stargazing technology would see major progress in the centuries leading up to the 1900s, starting with the patenting of the telescope in 1608 by Dutch inventor Hans Lippershey. This device was originally meant for use on the high seas, but using a technique pioneered by Galileo a few years later, the telescope was developed into a powerful tool for astronomers to observe the stars. In the late 1600s, Isaac Newton would help pioneer the reflecting telescope, which used corrective mirrors that allowed telescopes to be more accurate whilst remaining compact. All of these telescoping advances culminated in 1929 when Edwin Hubble used the massive Hooker telescope at Mount Wilson Observatory to develop his theory of a constantly expanding universe. This discovery captivated fellow astronomers and motivated them to push the limits of telescoping even more. Astronomy would soon experience a major leap with the discovery of the astronomical radio source by Carl Guth Jansky, leading to the development of radio telescopes that map the cosmos using electromagnetic radiation. Earth's magnetic field, along with light pollution, still presented an insurmountable hurdle for even the most advanced telescopes. This led astronomers to question if they could observe the cosmos from space itself. A well-known astronomer named Lehman Spitzer, who would later become known as the father of Hubble, strongly advocated for this approach. By this time, rocket technology was becoming advanced enough to deliver large payloads to orbit, and Lehman Spitzer's idea was being seriously considered. During the space race, NASA launched several orbital observatories into space. Though these were a success, they were meant as a prelude for a more impressive space telescope. With both the means and the motivations to create a large space telescope, it was only a matter of time before Hubble's development would begin. This process began with Lehman Spitzer, who rallied with the National Academy of Sciences for a large space telescope. Their combined efforts would lead to the creation of a large space telescope committee that Spitzer would lead, which was tasked with laying out the scientific objectives of the project. At this time, other astronomers, such as Nancy Grace Roman, also began campaigning for this idea to become an official NASA project. NASA would eventually form two official committees to flesh out the project in detail, with one focusing on the scientific goals of Hubble and the other focusing on its design. By this time, however, NASA's budget was being cut on a yearly basis, and consequently, Hubble's designers were forced to make several design compromises in order to save money. Hubble's final design, however, was still a groundbreaking satellite. It would have powerful optics, a 15-year service life, and interchangeable parts that could be serviced in orbit. With the backing of many influential astronomers and aerospace firms, the Hubble program's funding was finally approved by Congress in 1977. NASA employed several contractors to help construct Hubble. Lockheed Martin, in particular, was tasked with not only building Hubble's structure and computing systems, but also the overall assembly of the telescope. A series of construction mishaps and financial woes plagued the project. In the end, NASA had to cut a deal with the European Space Agency to help fund the project in exchange for sharing its data. In 1985, Hubble was nearing completion, and NASA officials began planning a space shuttle mission in 1986 to deliver the telescope to orbit. The Challenger disaster in the same year, however, led to a storm of grief and scrutiny within NASA that delayed Hubble's delivery. Many questioned the safety of the space shuttle and the viability of NASA in general, and it would take 4 years for NASA officials to regain the confidence to launch Hubble. In April 1990, Space Shuttle Discovery was launched from Cape Canaveral with Hubble in tow.
Off of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
As Discovery soared through the atmosphere, centuries of human curiosity soared with it. This mission would be the highest orbit ever achieved by a space shuttle at that time. Hubble was released in due time and began surveying the stars, but as astronomers began analyzing the images taken by the telescope, they were confused to see that they were blurry. A small imperfection in Hubble's large mirror called spherical aberration had ruined the telescope's optics. News articles at the time blasted at NASA for its failure and even expressed doubts on whether the telescope would ever achieve what it was meant to. In this dire situation, the combined strengths of NASA and a rising Colorado aerospace firm would save Hubble. NASA had already been working on an improved wide field camera to be installed on a service mission, and it was simple enough to correct the visual blur from Hubble with it. However, another device was needed to rectify the optics for Hubble's other instruments, which couldn't just rely on a better camera. Ball Aerospace answered to this need by developing a system of small corrective mirrors known as CoStar. To install these devices required the most difficult human spaceflight ever attempted.
Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
In 1993, the first of Hubble's servicing missions, STS-61, was launched to repair the fledgling telescope. 7 astronauts labored for 11 days to install the new instruments, and for their efforts, the frontier of space exploration would be changed forever. As an observatory soaring at 17,500 miles per hour far above the light pollution of city streets, Hubble was certain to make key scientific discoveries. Hubble has made more than 1.3 million observations since its deployment, allowing astronomers to calculate the age of the universe, discover the moons of Pluto, and observe millions of years of astronomical history. The Hubble Space Telescope not only fulfilled its lifespan of 15 years, but far exceeded it. As of recording, the telescope is still observing the cosmos, 32 years after its deployment. From 1993 to 2009, Hubble was serviced several times, receiving upgraded instruments that allowed it to make even more discoveries. In the long term, the Hubble Space Telescope has instilled confidence in NASA that has led to the development of the James Webb Space Telescope, which is slated to be even more groundbreaking than Hubble. Hubble's impacts were not exclusive to the frontier of space exploration. The company that rescued Hubble with the CoStar system, in addition to manufacturing both Hubble and James Webb's modern instruments, was Colorado-based Ball Aerospace. The company that constructed Hubble's exterior and computing system, while also managing the telescope's overall assembly, was Lockheed Martin, another key player in Colorado aerospace. Both of these firms, partially as a result of Hubble, have become a formidable economic force in Colorado. Today, the second largest aerospace economy in the United States exists in Colorado, with massive aerospace firms such as Lockheed Martin sharing ground with exciting startups such as Boom Supersonic and Sierra, all working towards the next steps on the frontier of space exploration. In this way, the story of the Hubble Space Telescope is not only an example of a major human achievement. It is also a story of how a community can be invigorated by projects that, while benefiting humanity as a whole, can also have spectacular effects on locals, in this case, our community of Colorado. Ultimately, the Hubble Space Telescope is a Colorado chapter on the frontier of space exploration. It's also a Colorado chapter in many frontiers, not just space exploration or economic development, but also in the frontier of mankind itself. Hubble's legacy is crucial for the future of humanity, not because of what it's done, but because of what it means for us. Our ability to understand and observe the universe we call home will lead to our ability to survive and expand, even as our own planet suffers the burden of humanity's environmental interference. The perseverance of Hubble's creators, constructors, and astronauts who labored to overcome adversity in even the most desperate hours will be the awe of many dreamers and doers for decades to come. The discoveries made by Hubble and its promising successor will be a key to humanity's progress for centuries to come.